at 39 degrees, 66% humidity.
Okay. Yeah. I used to have a drying room in my finish line where we keep it at 50.
Okay.
That's toasty.
Yep, it's pretty warm. So this is a Katil Kiln. They're out of France. It's actually technically a conditioning kiln, so it's only to bring it down a few points of moisture. But it can maintain the moisture in there as well, which is the bonus of it as opposed to a dry kiln.
Yes.
So when we have an order brought in, there's not a rush to bring it into the building. We can maintain the moisture in there as well.
Right. So you're basically using this as a cleaning room for production.
That's right.
It seasons as well as it's drying. As well as it's drying it out, it keeps the moisture at equilibrium moisture.
That's right. So we bring stuff in, we restack everything with kiln sticks. Once we've restacked it, we bring it in here. We segregate everything based on whether it was an FSC certified wood, the size of the wood, the grade of the wood, the species of the wood, so that it can all be drawn out. Our ERP will dictate what we have to bring out to the line. We'll enter that into the lead neck line. It'll verify that we're using the right stuff, and then we process it.
So other than the FSC requirement, obviously, you segregate by species and grade to keep its structural characteristics similar?
That's right.
Okay.
So if engineering designs a panel or a beam that needs MSR wood, we'll have MSR wood set aside for it. If it's number 2 or better, that's usually your core layers. Number 1 or better, it's your top layer. And then depending on which species you're calling it as well.
So it's both a visual as well as a structural.
That's correct. Now here is we're entering what's called the lead neck line, and the lead neck line is sizable. It takes up about 60% of our 137,000 square foot building. So in the back portion, we go through and we sort through the number 2. There's weighing restrictions that unfortunately, even though it's considered number 2, we have to filter it even more. And then we bundle that into different groups. It gets dried in the kiln, as you saw, and then we put it on an in-feed conveyor. So we're generally running 2x6 for the most part in 10 to 16 foot lengths. And the system raises the entire bundle up, lifts it with a vacuum section, and then pulls it in so it's a single layer. At that point, you'll see an arm swing across there on the right, and that's pulling the kiln sticks off so that we can reuse them for the next batch. After that, the single layer goes in and it gets singulated into board by board. It gets squared up and it goes through 2 alignment stations. So the operator there is inspecting it for quality, and they're pulling it out if the end needs to be cut off. So there's restrictions on how close a knot can be to the finger joining area. And in this case, Mike is going through and he's adjusting it to make sure the knots are cut off and that it gets rejected if there's a visual damage. Maybe it's a broken board or there's something that got through the initial quality process. Then the board gets datum to the other side, and you can see here that these Mark and Steve are pulling the boards across and doing the same thing on this side. Just prior to this, there's also a moisture check, and the moisture reader's determining that we're 12% plus or minus 3%. And if it is outside of that window, it'll get rejected in the zone that you're looking at. So after that, the boards get tipped up 90 degrees on end, and they get inserted into a set of these spring-loaded clamping fingers. And this holds it through the finger joining process. So the board will go down now that it's on its edge, and it'll get fingers cut into the ends of the board. And immediately after the fingers are cut, adhesive is sprayed on one side. The board moves through. The process repeats on the other side, but then it puts the hardener. We're using a 2-part epoxy so that when the 2 come in contact, they bond together. Everything here is controlled by a single computer, so we enter in the size of the billet we want, the makeup of the layers, the computer system determines the most optimal way to process all the billets. So it's not necessarily making one billet in its single form. It could be processing all the visual grade lumber for all the top surfaces of 3 billets, and then optimally do a changeover and go into the number 2 grade at that point. So the operators get a screen that gives them a list of all the work orders that are coming down the line by quantity of boards, so that they know as they're going through that they need to make 25 of 30, and then eventually they'll get to 30 of 30. So at this point in the video, we're running at about 50% capacity on the line. Every other slot is empty, and we can process 44,000 cubic meters of wood a year across 2 shifts, and we can make a 16 meter by 3 meter panel in under 30 minutes. So you see a close-up of our finger joining blades there. That is our glue head. And then the boards go through and everything's datum together. So we can do anywhere from a 2x4, it's the smallest board we can do, all the way to a 2x12. The curing time for the 2-part epoxy is about 10 minutes. So keeping this section of the line continuously operating is pretty critical for us. After they are flipped back onto their flat, the boards are put onto what's called a metering conveyor. So basically the boards are going down. The board that is behind the stack gets sped up so that it's put together.
One side with one adhesive on one component, and now the other side with another component, so we bring them together, then we create reaction. Exactly. Okay. Wow. Okay. As opposed to trying to mix them in place and then do it. That's right. You do longer open time, that's for sure.
So our entire line from lumber introduction to the outfeed is completed by the Lednick line, but then there's many pieces that are included. So you'll see a lot of the piping. That is all feeding back to a dust collector that Taurus Graco, Kyle, was an instrumental part in leading us to making sure that that was an absolute success for us. So the lumber comes down, and this is really I guess the biggest strength for Lednick is the finger joining technology. So this is a 50-ton press that operates in 2 segments. The left hand is a fixed press, which is holding the board, moving at about 2 meters a second. The back one is a floating, which puts the pressure. And then the orange device on the left is a flying saw. So it speeds up to meet the speed of the wood, it clamps it, and then it cuts it to the length that we need. So the software that runs the whole line is dictating the length of every board. As the boards come in, they're getting cut to a millimeter tolerance, anywhere from 8 meters to 16 meters in length. Those boards will then go down through a curing process at that point.
Chris, is that software proprietary to the Lednick line, or is it?
Yeah, it's called XLAM. It's got a base software that they customize for every single line that they have. There's different configurations of lines. So the cure zone could be, in our case, it's 3 conveyors stacked on top of each other. In some of their systems, they go as many as 8. It really is dictated by the overall volume of the line.
Okay, thanks.
So what happens now is they've started to group the lumber together into groups of what will eventually become a layer, and they have multiple levels so that if they need to bypass one level by another, they can. So that that takes a little bit back to the comment I had about they want to make all the premium wood first so that we don't have to do as many changeovers. And then they eventually want to go back to number 2, but within a panel, they're mixing and matching. So this gives them the ability to pull what they need at different times and bypass it by other ones. So everything's packets of information that we track through the software. So we have a traceability at all times of exactly what time it went into the curing process and what time it came out of the curing process.
How are you monitoring each of those groupings? Like, are they tagged in some way, or is it just by the order that they've gone into the line?
They're actually all digitally tagged into groups that's tracked through the software, and every time they're released from one area to another, the digital tags are moved to the next section. But it gives us an ability, so if we have a glue issue, we can ensure that everything got the proper curing time. And as well, if we need to make an extra piece because something broke further downstream, we can track where that extra piece is and make sure that it's being delivered at the right time. So one of the biggest, most critical things with a line this size is the safety of it. So we have approximately 11 safety zones, and those safety zones allow us to go into different sections of the equipment safely while operating the other areas. So a lot of the time you'll see overhead fencing as well as vertical fencing, and that just allows things on top of the walk-in areas to be operated. So that the second part of our process is the planers, which we'll get into.
Okay.
Yeah, they do it phenomenal. They actually have this really nice machine for a different purpose, but it's a rotary horizontal drum. It's more like a milling head.
Oh yeah, okay.
But they use it for planing. It's quite a unique system as well. This is really where Lednick started. They started making planers, and they grew from there.
And they started building out the whole feeding system.
That means you're going to have that many cuts per inch. You're going to have such a very smooth surface for your next levels, because you're not going to have the ridging that you come off of a traditional planer when you don't have enough, when your KPI isn't enough.
And as part of the certification process, you actually plane the boards, you set them aside, and the auditor will go through and measure them at different points.
Yeah.
And they all have to be within a certain tolerance.
Okay.
And it's quite a tight tolerance.
I bet. Because you won't get glue bond if you have too much gap.
Exactly.
So Ryan, I'll just pause there. So a little bit about the process here. So every time we do a dimensional change, we run that process that I described in the video, and it's a 6-point process, 2 points in the middle, 2 points on each end. All 6 points have to be within 0.2 millimeters of each other to ensure proper glue adherence. So our quality process is quite tight. We run a number of destructive tests on our finger joints. We run a number of measurement processes on our planing. And then as well, we have to look for different scallop marks to ensure that the planing is consistent. And then there's a certain number of board feet that we can run before the next quality measurements are triggered. So this planer usually is taking about 1.5 millimeters off of each side for us. We can go up to a maximum of 20 millimeters of removal with this planer on a single pass. So we can take a 38 millimeter thick board down to basically 18 millimeters in thickness if needed.
Wow. That's a heck of a precision. 0.2 millimeters is the precision you need for that?
That's correct, yeah.
Okay.
And all of that's dictated by the PRG 320 certifications that we follow, which is our overarching guidelines for our entire process.
Wow.
And again, all of this is dust extraction to a Hawker Polytechnique dust collector that was supplied by Torres Franklin. So immediately after the process of planing, we apply 2 beads or 3 beads of hot melt glue. Those hot melt glue beads are keep the boards together during the next part of the process. As well, we put 2 beads of white glue, just your standard white construction glue on there. And that allows us to minimize gaps from opening up between the lamellas as the wood starts to dry. So the boards that are now cut into whatever length you need, they go down this press that it's a little hard to see, but you see a row of orange plates. And what happens there is the boards go down, they've been glued on the edge, they get pushed sideways into the board that was in front of it, and we keep pushing boards across until we now have the full width of panel that we're looking for. So the board is effectively 1 layer thick, but it's the correct width and length. And we keep building out these layers. Again, the layers can be built in the most optimum method using the PC algorithm, so that we're not making one premium layer or one 35 millimeter layer and then having to switch over. We'll make all of our 35 millimeter layers, then we'll make all of our 17 millimeter layers, and then we'll go on to the next grade after that. And as a result, we have a 4-stack conveyor system that's got 21 slots, which allows us to effectively have a queue of 21 longitudinal layers at any given time. So if we're making a 5-layer panel, we can effectively have 4 panels stored in our conveyor system. So the panel then transfers out onto an elevator, which lifts it up, and it stores it into one of the 3 layers that we have.
More than 10 minutes before, you spray the board with a primer, which assists the adhesive. Oh, and that's Sprinklers really assisted us with all of our adhesives and they supply.
So once we've sprayed that primer on, we have approximately 8 hours to execute the glue adhesion before we have to reprime the boards. So the system ensures that you don't start and stop things until you're ready for it. So after we take boards through the planer, we have to lay those boards up into a final panel within 8 hours. So this is where, so the basis of CLT is that every layer is alternating to the layer below in direction. So if your first layer is longitudinal, your next layer is rotated 90 degrees to be transverse. So the bottom conveyor section pushes the panel onto this table. It's approximately 3 by 16 meters, and the panel gets pushed across and clamped, and then a saw runs across, and you can see it right there, cuts the panel to the dimension that's needed, and then we push the panel across and we repeat the process. So at the end of this, you end up with a stack of wood that'll eventually become your cross layers. So typically in our process, we're using spruce pine fir. We're usually using premium and number 2 grade. We can use number 3, but we don't at this time use it. We can also use Douglas fir as well as other species if needed, but the majority of CLT is made out of spruce pine fir. So the interesting part with a system of this size is the access to different areas. So as you go through, you'll see that there's a number of platforms. All of our platforms were made out of our Quebec facility. We had a strong focus on making sure that there was a wood element within our facility and then we utilized it to showcase some of our product. So in this, you'll see the cross layer. It's a stack that's going down. It will be queued up, ready for the layup. And we'll queue up 8, 10, 12, depending on the number needed. We can also take them off and store them should we need to have a whip in progress for that for a later time. And then the vacuum gantry picks the layers and puts them back together to effectively make one full-sized level of the layer.
Fish markers. So what happens is the lending system will scan the barcode that we set on our good at a time, which is coming from our ERP system, okay? And then once it gets in, they have points that are work in progress. So this technically is a work in progress point. So if we were to remove it from the line, they would output a label for us with a barcode. We would take that barcode and apply it to that pallet of wood. And when we reintroduce it, we would rescan it to say, this is what we're putting back in, and they would say, error, this is not what you should be putting into this particular order, or yep, that's correct, keep going. And then on the far end, there's another label printer coming into the standard. Okay, yeah. And now we'll define with their programmers to match what we're looking for to put it back into our ERP.
Which will identify it to your installation drawings and all that. It's part label for that application.
Would that then also pull up your CNC file, like the barcode, will that be linked, or is that kind of two separate systems there?
So our engineering system imports a column into our ERP. It then gets a unique identifier at that point, and that unique identifier is really the tracking syntax for everything that goes after that. So when we get down there, that barcode will go back into the ERP will reference the engineering drawings, and everything will cascade through. All in that in-force object.
Nice.
So one of the biggest challenges of a facility like this is the amount of technical knowledge that needs to be transferred from the vendor into really our team. So we've had a huge investment into operators, maintenance staff, controls engineers, CAD engineers, to really ensure that we get that translation. So we started the installation July 15th of 2020, ran our first panel with the assistance of Lednick by December 9th. And since December 9th, we've been working with the Lednick to transfer that knowledge over to our team. And as of this week, there's no laptops on the line anymore, and the operators have been operating the line in full capacity for the past 3 weeks.
Chris, during that knowledge transfer, is Element5 building sort of inventories of systems and processes to have a legacy of that knowledge?
Yeah, so all the way along, as the training occurs, we start creating SOPs and training documents that really records everything that was done by the operator on a regular basis, and then the quality checks that need to be done, and we bring those two databases together. So what you see here is we have two gantries. The gantry on the right handles the longitudinal layers. The gantry on the left handles the transverse layers, and the table in the middle moves back and forth. So once you've placed your first layer on the table, it goes out, it gets glue applied to one half, and then it gets glue applied to the other half on the way back. There's a very specific amount of glue that you have to apply, and you have to stay within a certain range, and then you have to do destructive tests to prove that you were within that range at all times. So in this case, the conveyor is moving the proper panel down from the 4-stack conveyor system, and the gantry will go over and pick it up after it's been datumed. The Glulam vacuum system, it's an OOST glue head, and then obviously all integrated into a Lednick system. There's calibrations at the start of every shift, calibrations midway through, and then quality checks as well. So all moisture in the building has to be maintained above 50% for this glue application to work. So there's a moisturizing system as well in the plant. And then there's spray nozzles, which put a mist down on a specific volume of water onto the glue as well to ensure adhesion. So this is all servo controlled. So as the panel changes in dimensions, the table will start and stop at different points so that you lay the glue in the exact amounts. So in this particular case, that 16-meter long table is making about a 9-meter long panel. This is a polyurethane glue from Henkel that we're using. Henkel was extremely instrumental in ensuring not only the delivery of the glue, but really training our team as well to understand the storage, the SDS parameters, the safety parameters, and ensuring that the proper adhesion was done at all times. So they really walked us through that process. So there's a spur off of our line, which makes Glulam beams. So we can make columns, beams, as well as panels for floors, roofs, and walls. In the case of making a Glulam beam, we follow 2 different standards, depending on whether it's an American project or a Canadian project. And we can make a beam that is 285 millimeters in width, 1.5 meters in depth, and up to 16 meters in length. So it's a little bit different because you're starting to use MSR lumber at this point, and we do a second grading step to grade it for a visual standard. We track it through and we unload it with that vacuum system that you saw there. We then reorganize the wood to be in the order that we want to make it. We put it back on with the vacuum system, and it goes down these roller conveyors where it picks up polyurethane adhesive again. The press would open up, the boards would get organized by the operators in the area that I'm entering.
So the board will come down like this glue, you'll flip it up on end, and you'll build your beam out this way.
It's not a manual process where someone has to flip them.
That's one person on each end.
Right.
Once you've done this whole conveyor section flips up, and when it flips up, these orange bars goes in against these orange bars, that gives you your alignment, and then the hydraulic rams come down from the top, and they close only the sections that you're using.
And then once the beam's done, they exit out on these roller conveyors. So when we have a 1.5 meter capacity in the press, it can be a single beam with a depth of 1.5 meters, or it can be the summation of a number of beams that we've stacked on top of each other. The beams then go through a 4-sided planer to take off any basically misalignment and get a smooth surface to your finished dimension.
And
then this is back to the seat.
Oh, sorry, Chris. So that building we just saw a moment ago, was that the 4-sided planer? Just in that last
That is correct. Yeah.
Okay.
And that's specifically for the Glulam beam. So now back onto the CLT here. This is the X-Press technology. So this is another patented technology from Glulam. So the panel is loaded in on the actual platen, which lowers. They have a servo force rail that brings in and clamps the end to get its pressure. Then the sides come in for a specific pressure, and then the servos lower the entire overhead section. It's in 8 specific platens, and the platens that you're using lower down, and then airbags go off to get to 220 psi, and it sits at that pressure for 2.5 times whatever your open time of your adhesion was.
So what happens is it's in segments, and then in each segment there's individual airbags. And because of the airbags not having a rigid mount,
they conform to whatever the surface is. And if they're thicker at this end than this end, all the airbags make up for the deviations in the panel.
Oh, that's smart.
Yeah, that's an enormous price. So doing the pounds, like,
That'd be one way to put it,
if it's 221 psi at 56 square meters, you do the calculations per inches, you're like, it's like in the vicinity of a million tons.
Yeah.
Well, and the charging of the press is counted as part of the open time. So until it reaches its charge pressure, that's all part of your open time.
So it's only while you're under full pressure that you actually count curing time.
So we pre-charge at a higher PSI. We're around 260 PSI. We pre-charge our tanks so that when we open them to the press, we equalize out at the 220.
Right. So it's not like you have to build up that pressure once it's there.
God, awful amount of
So
pressure
as soon as
for
we
square
release
footage.
that air out, we start building the tanks back up for the next cycle.
Nice.
Then when we're done, we pass everything through IMEAS drum sander. IMEAS is an Italian company that has put their sander on all of Lennox lines, and we sand up to 2 millimeters off in the thickness of the panel, and our goal is to get within 1 millimeter or 2% of the thickness of the overall panel thickness.
So Chris, you were describing in the video there, looked like some layers were passing before one another. Does that pertain to this sander, how the product's flowing through there?
Yeah, so on those conveyor sections, the platens that the billets are sitting on, there's a bit of a shell game that the computer is playing there. So as one goes into the press, the one that just got unloaded has to go back into the layup area to make sure that there's not a traffic jam. So the conveyor system there is pretty sophisticated in tracking where those platens are at all times. So that's one of our sanding belts that's about to go in. We change our sanding belts on a regular interval. We use anywhere from an 80 to 100 grit belt. Everything again tied into our dust collector. The opening on the sander can be as high as 380 millimeters, and we can sand as wide as 3.2 meters in a single pass. So then after we're done, so we have a transverse conveyor that takes the panels to the other bay if needed, at which point we have two 20-ton cranes that can work independently or in tandem, and we load that into an SCM CNC overhead 5-axis bridge. On this CNC, we've got up to 880 millimeter diameter saw blades. We have a Mortison chainsaw, end mills, porcupine bits, routers, so we can do pretty much any cut that we need to do. So the main process here is to cut the 4 edges of the panel square, cut out the smaller panels based on how we nested them, and then put in any details that our engineering department has included into the design, whether that's pre-drilling holes, access slots, M&E openings, etc. Since the time of this video, we've installed 2 more CNCs, so we now have a Maca CNC, which is actually slightly bigger than this SCM, and we have a beam CNC from a company that's escaping me right now, but it's an Acetra. So our process is that every part of our buildings are drawn in Rhino or CADWorks in full 3D. So when our engineering team finishes the design, we have every hole, every slot, every cutout that's in the entire building. They break that down into individual models. Those models are all translated into BTL files that are sent to the CNC programmers. And then we don't even use 2D drawings for the majority of our parts. We just execute to the 3D model that's been made.
Yeah, it is. It's quite light for aluminum, not a casting, a milled aluminum piece. But just the size of that piece, the end force, like the torque it's going to put on that spindle is just.
This portion of the facility is for all of our future value add. So as the product's coming out and we've machined it, there's moisture barriers to apply, there's fire retardants to apply. We do what's called clips, so we put the actual moisture protection, the insulation, the strapping, and it becomes a complete wall. And that wall can just be craned right into place.
So when we talk certification, is that like a building code? Like you have like a building code certification that you need to meet, or
There's a series of certifications. I mean, so for CLT, everything is excuse me, governed by PRG 320. So PRG 320 tells you how you do it, and you need to be accredited by a third-party certification company who actually does destructive testing on the panels. So we're using PFS Tico. They give us a test plan where we need to cut a panel into certain shapes. An auditor comes, he witnesses the panel getting made, signs different sections of it. So wherever he puts a signature, we cut a piece around that. We then package it up, we send it to PFS Tico, and they run it through shear test, 3-point bending test, delamination test, and then they give us our certification based on that. And that is based on the layup you're doing. So you do a 3-layer, that's one. You do a 5-layer, that's another certification. If you're doing Glulam, it's a little bit different. So that's governed by ANSI and CSA, and you have to follow those guidelines. And again, you get certified by the oversight of PFS Tico, and so they come in, they audit you making those beams, they make sure you use the correct wood and the correct layup, you're in the test plan, they do a destructive test, and after that, you're certified for a specific set of layups. And then in the future, you want to do a different layup, you go through more certification.
and then so you've got that certification up front. What kind of an ongoing audit procedure is there to maintain that?
So then you have regular intervals where PFS Tico will come in and they'll do implant audits. So those implant audits are to make sure that are we following the processes all the way through the line to make sure that we're collecting the moisture readings, making sure that the wood that we're planning to use is being used at the correct times. And then we're doing our first offs, we're doing checks based on a certain number of board feet run. And then in-house we have a MetroCard tensile tester, an Instron shear tester, and full ability to do our own delamination test.
Okay.
So on a regular interval, we're doing that. They're going to come through and look at our books to make sure that were you auditing, what were your results, did you see anything, what did you do in reaction to the quality numbers that you got.
Very good. So it's a fairly stringent, well obviously it's structural, so you get a fairly stringent.
It's funny because our QA manager, she comes from the food and beverage industry, which is obviously an extremely tough quality system to manage. And even she says this might be more.
Okay.
So Maria's quite a smart quality manager, and even she says it's very, very involved.
Doing your fire rating, your structural load, your wind shear. I mean, you can't just say, oh, PN signed off on it, we're good. It's a bit more than that.
Well, and then the nice thing about Element5 is because we have all the in-house engineering capabilities, they're really giving us a product that is specifically made to adhere to all the design constraints that they've set out. So when they get to a panel like this and they say, this panel, this stress grade,
you know that they've already taken into account wind loads, snow loads, and all the structural details. And that helps our customer that if they don't have those abilities, we can lend our hand in them. And this thing is cut to precision.
All right, I guess we get to jump in straight away. My name's Sarah Hicks. I'm Communications and Marketing Manager at Element5. It's my pleasure today to moderate the questions coming from the audience. With us today are two key people in production at Element5. So we have Chris Latour, who is our VP of Manufacturing Engineering at the St. Thomas factory, as well as our company founder and VP of New Business, Patrick Chouinard. So during the presentation, we had a number of questions already come in. And Patrick, I know you're gonna laugh at this one because the very first one was our favorite one about the price of lumber. So the question is, when it comes to CLT, how much are you affected by the lumber cost in the market right now? Same increase or less?
Yeah, so happy to address that. So one of the advantages that Element5 offers in the market is the fact that we're vertically integrated. So we control our supply chain right from the forest floor through to finished product. We have established strategic relationships with key vendors in Northern Ontario where we source all of our materials from. And those are quite strategic. Our largest investor is also the largest investor in sawmills in Northern Ontario. And that investor is the chairman of our board of directors. And two other members of our board are also in the sawmill industry. So it's quite a close working relationship. There are ways for us to mitigate the price of lumber. So because of that strategic relationship, they help us to overcome some of the dramatic peaks and troughs in lumber prices. So they sort of level out the commodity prices for us. Because we source most of our material from a strategic few sawmills in Northern Ontario, we're able to predict the volume of wood that we will require over periods of time. So we essentially, buy futures with those suppliers. And also every year we see the same sort of trends in lumber prices. So you see the same peaks and troughs consistently over, say, the last 5 years. And we know that lumber prices drop in and around the September-October time frame when the construction industry starts to slow down. And that's when we are able to buy large volumes of wood and to stockpile wood at lowest prices in our yard in St. Thomas.
Great. Next two questions are pretty straightforward. Chris, I'm going to direct them to you. One person asked for a reminder what MSR lumber was.
Sure. Yeah, MSR is machine stress rated lumber. So it's got a higher stress rating than normal number 2 grade lumber. And in the CSA standard, there's a specific call out for the tension side and the compression side of a beam to have MSR lumber of a certain grade.
And the next question is about our certification. So I saw this question actually come through before you addressed it in the pre-recorded video, but I don't think it hurts to reiterate. So can you please repeat the certification that our plant complies to?
Sure, yeah, we have a number of certifications. So on the CLT side, we conform to PRG 320, which is the standard for CLT lumber. We have certifications in 175 millimeter, 139 millimeter thicknesses, and 105 is due in about a week, and 9 layer, 7 layer, and the remainder will be about 3 weeks after that. For Glulam, we have conformance to CSA 0122, 086, and 177. And we're in the progress of getting the ANSI standard for US supply.
Thanks, Chris. So the next question, I guess for efficiency, what file formats design do you accept for processing? We are Revit based.
Yeah, so we accept a variety of formats. So Revit, Rhino, CADWorks, step files. We can convert back and forth using all of our software platforms and take them to BTL.
This sounds like a supply question. So what is the lead time for laminated beams?
For Glulam laminated beams?
I'm assuming so.
Yeah, so for CLT, it's a little bit longer because there's a little bit of coordination that needs to be done. For Glulam, it's a little bit simpler because you're choosing standard widths and depths, which we're building inventory of. So if it's from an inventory item, it's about a 4 to 6 week delivery. And then for bigger items that wouldn't normally be, we'd be closer to about a 6 to 8 weeks.
This one, is PRG 320 recognized by Canadian codes?
Yes, it is.
Here's a one about waste. So with all of the cutting and planing, what's the percentage of material waste during the production process?
It's about 3 to 5% waste. The biggest factor for potential waste is in the nesting of the panels within a billet. So we make the billet as large as possible, and then we'll cut smaller ones out of there. So in a very large 3 or 4 story facility, that waste goes down because the panels are bigger. But if you were to do a house that had more limitations in width and length, we have to work a little bit harder to get that nesting as efficient as possible.
This is probably a tricky question to ask, pricing related. What is the premium of your laminated timber compared with steel? So maybe
Patrick,
that may be a question for Patrick.
Sure.
Give you the easy one, Patrick.
Yeah. Well, we go up against concrete and steel on a regular basis, and you know, it really depends on the design of the building largely. And you know, with prefabricated structures, it's not only about the cost of the materials, it's the complete solution that you're getting, which is a, you know, an integration of the, you know, prefabrication, you know, the cost of the construction, you know, so it's not just the advantage in mass timber is strictly not a material cost comparison between CLT and steel or concrete, because it's more, you have to look at the overall picture rather than just the component parts. But you know, we've just recently came out with our affordable housing solution. We bid a project for the YWCA in Kitchener, and we did that project at the peak of lumber prices. And we went up against all of, or a majority of the other people in the industry that are providing affordable housing solutions that are either in wood or in steel. And we were still able to underprice our competition, and we were successful at winning that. So we definitely have a very competitive offering. You know, it just makes sense in the future of this industry to be prefabricating buildings off-site and shipping them to site. Our pricing has come down considerably. We used to import a lot of materials, but now we source everything from Ontario. We manufacture locally, we deliver locally, and that's driven down the overall cost of our solutions. So we are very, very competitive against concrete and steel.
And tying into what you just said about sourcing, Patrick, the next question is about the location of the plant. Was there ever a consideration to locate your manufacturing facility in Northern Ontario, closer to the source of your raw materials?
Sure. Maybe I can touch upon that. I don't know if, Chris, you want to add to that, but so we did that analysis, and you know, we thought it would make sense to locate the factory closest to where the materials are sourced from. But when we really worked out the economics and the shipping issues and transportation cost issues and such, it made economic sense for us to locate the plant closest to where our end customer is. And the advantage of being in St. Thomas also is from here we have ready access to the whole central and eastern seaboard of the United States. We have ready access to labor. St. Thomas was a little depressed at that time, you know, because of what happened in the automotive industry. And there was a lot of people that were, you know, we had a pool of resources for labor. We have access to local universities where, you know, some research and development work is done in mass timber. So when you combine all of that, it just made so much more sense economically and, you know, practically from a business development standpoint to locate closest to our end customer.
The next one's not quite related. So do you publish STC ratings with your CLTs?
No, we do not at this time.
Yeah.
Easy peasy.
But we deal with STC ratings in every design, you know.
Yeah.
Sorry, for example, in our, you know, we're a solution provider, and that entails working with a number of consultants as well. So, you know, we're not experts ourselves in acoustical performance, but, you know, when we put together the YWCA project, we had, you know, general contractors, engineer of record, acoustic consultant, fire consultant, envelope consultants, and we worked, you know, as a consortium with consultants on every project. So we have to address the STC rating in pretty much every solution that we design, and there are ways of achieving the STC ratings that are required for pretty much every typology that we're involved in involving wood.
Next one is a glue question. I'll direct that one to you, Chris. Are the glues formaldehyde free, and how long do they last?
Sure, yeah, we use a polyurethane glue from Henkel, and the polyurethane glue is, when it's in its inert state, it's emission free, and it's, I'd have to look it up, but it's plus 25 years or more. I'd have to check the exact number on that.
This one's about the sanding belt. Your sanding belt is up to 3.2 meters. Is this the maximum dimension of the panel width?
No, it's not. So we have the ability to make a 3.5 meter wide panel, and we can sand up to 3.2 meters wide. And then in cases we can sand beyond that, but it just is a more manual process. So the sander is the automated one for 3.2 and below, and then we go into hand sanding after that.
Are there any modular sizes you would recommend to minimize cut and waste?
Yeah, so the press has, it's a little bit of a complex algorithm, but we can do 1 millimeter increments once we get above 2.4 meters. And then for sizes below 2.4 meters, we go through a nesting exercise to get panels side by side or end to end. And that allows us to make 2 panels at once, cut down the middle, and get 2 panels out of that, minimizing the waste with just the 6 millimeter thickness of the saw blade.
What kind of lead time / delivery is expected for small projects, part 9?
So generally what we've been seeing is that the coordination efforts are, I'll say, the longer the lead times to get all the M&E sorted out. Once the drawings come to our floor, the shipment goes out in about 6 to 8 weeks.
Awesome. The next question I might be able to answer. So is there potential for a post-COVID factory tour? Absolutely, yes. Currently, we are not really doing tours, obviously, but if you want to email me specifically, I'm the one maintaining the waiting list. So my email address is Sarah, S-A-R-A-H, at element5.co. You can email me anytime, and if you're interested in a tour, absolutely just let me know and I'll add your name to the list. And once we are rolling with tours, I'll be in touch. Next question is about lunch and learns. Yes, we do those too. So again, reach out to us. You can reach out to me. You can reach out to Patrick as well, or you can use our general info at element5.co to request a lunch and learn, and we will connect you with the appropriate person on our team to deliver those educational sessions. Next one, with a glue lifetime of 25 years, does that mean for the structure of the building in 25 years it needs to be demolished? Well, I'll let you,
No.
you guys can probably both answer that one.
No,
Sounding no, but go ahead.
It just to say, Chris, I just happened to be looking at the glue technical information just this morning, coincidentally, and the life expectancy is in fact 100 years.
Oh, 100 years. Sorry about that.
So that, I mean, unless anybody with us still in the audience has more questions, I'm at the end of the question list for now. So we're doing pretty good on time. We have another 5 minutes, but I don't know. Yeah, I don't know where to take it from here. Maybe Patrick White, our moderator, you can jump in and let us know what you'd like to do in the absence of additional questions. Or maybe not. Does anybody want to vamp for a few minutes? Yeah, no, we've definitely addressed everything, and there don't seem to be any more questions coming through. So again, I just encourage anybody in the audience that's interested in knowing more about mass timber or about Element5 specifically, or if you have a project that you'd like to discuss with us to find a suitability for using mass timber in your project, we would love to hear from you. So we're super accessible. You can reach us by phone. Our toll-free number is 1-888-670-7713. You can reach us by email. You can use the info@element5.co, or you can reach out to us directly. We have some of our emails are published actually on our website, which is www.element5.co. I have a thank you here from the moderator saying thanks everyone. So it's possible that we've now been disconnected. So I'll sign off. Thank you, Chris. Thank you, Patrick.
Thank you, everyone.
Thank you everyone for attending.
Thank you.